Hello, this is Industrial Instrument and Sensor 7 modules. Now we are doing skill test number 5. Now, the work order they received stated that the room of the greenhouse is quite warm and one of the exhaust fan did not turn on. So what is the problem? Let's dive in. By looking at the local temperature here, we see that the temperature is 28 and the humidity is 75%. As we know, when the humidity is higher, the exhaust fan should turn on to exhaust out all the heat. Let's go to the field site and take a look. What is the problem? Okay, we notice that two exhaust fans turn on, but one of the exhaust fan was not turned on. So let's go to the control room and take a further look. We look at the lighting of the control panel and we notice that two exhaust fan lighting are turned on except another one. Okay, so we know the problem is not only the exhaust fan one did not turn on, its lighting also did not light out. So we can look at the drawing, the schematic drawing, to find out the further problem. Okay, this is a schematic diagram. As we know, schematic diagram divided into two types: the power type schematic diagram, the control type schematic diagram. Power type we call it electrical diagram. The control type we call it loop diagram or signal diagram. Mostly deal with the signal control, etc. Okay, by looking at this schematic power diagram, we notice that this is the M1 motor 1 or exhaust fan motor 1. This exhaust fan motor 1 did not turn on when we visited the field site just now. So it can be due to the overload relay or the motor contactor did not trigger the close. Okay, so what is the exact problem? Actually, troubleshooting PLC circuit is not really difficult. In fact, it is very easy. We can always monitor the PLC input and the PLC output LED status. That's all. From there, actually, we can see a lot of the problems. Of course, you got the access to the PLC logics programming is even better. But life is not always perfect. If we do not have the access to PLC logics programming, at least we must have a basic circuit like schematic diagram. It's even better we got the wiring diagram together. If don't have, at least we need the most basic schematic diagram. Okay, this is a schematic diagram. So now we can look at the schematic diagram for the control diagram. Okay, the schematic control diagram can be further subdivided into few types. Okay, the PLC input circuit. This is a PLC input digital circuit, PLC analog input circuit, and the PLC RTD input circuit, as well as the PLC output circuit. Okay, this is what we call wiring diagram. Okay, this is a wiring diagram for the power circuit. Okay, power circuit, and the wiring diagram for the control circuit, which include the PLC itself, and also the also the wiring diagram for the control circuit, but mostly deal with the control panel lighting. Okay, etc. And also this is a control component. This is a power components. Okay, right. So always remember, when dealing with PLC circuit, always look at the LED status of the PLC input LED and the PLC output LED. Okay, we can see first, before we go to the control panel, let's look at the schematic diagram. Okay, this is a schematic PLC output diagram. We know that when we visit the field site, the exhaust fan number 1 did not turn on. That means the exhaust fan motor contactor coil number 1 did not energize. And also when you visited the control panel, we noticed that the lighting for the fan, exhaust fan motor lighting one did not turn on at all. Okay, that means these both did not turn on. So what is wrong with that? Okay, maybe one of the devices here, whether this PLC output switch, module 2 channel 0, the motor selector switch, the overload auxiliary switch, normally closed auxiliary switch, or the wiring here having internally open circuit, or there is a loose termination. Okay, one misconception when dealing with troubleshooting is we always think that, oh, because this component did not energize, so the problem must be from the PLC output circuit. Actually, this is wrong, because the problem not necessarily from the PLC output circuit, even though we know that while the component did not function is actually located in the PLC output circuit. It can be from the PLC output circuit itself, of course. It also can be due to the PLC CPU itself, meaning the PLC logics programming itself may be running on wrong program, download the wrong program, or the program is faulty. Actually, this kind of issue is extremely rare, if ever, so we can actually temporarily ignore this kind of problem. Okay, so the problem mostly can be from the PLC output circuit. Actually, it also can be from the PLC input circuit. Okay, just for information. So don't always have this kind of misconception. Okay, just like in this case. So what we can do is we try to measure the voltage at this point 3 of the motor selector 1. Okay, this is a live AC. So the AC current actually sourcing the PLC output switch module 2 channel 0, and then sync the external output load to the ground or common point or neutral. Okay, we put the multimeter black probe at the neutral or ground side. Okay, and then put the red probe at this point 3 of the motor selector 1. Okay, when the current AC current flow through, okay, to source the PLC output switch module 2 channel 0, okay, it will sync to the motor selector 1, okay, auxiliary switch overload relay 1, and then this external load of motor fan, exhaust fan motor contactor coil 1 and the motor lighting 1 to the ground or to the neutral. Okay, so when we put the red probe of the multimeter at point 3, the current flow through here we divided into two paths or branch into two paths. When I say divide or branch, it means a parallel circuit. So one side to the load, the other side to the parallel to the multimeter. Okay, if the outstream is open circuit or having loose termination, the voltage that we measure is 0. Note that this kind of measurement is always measure the condition of the upstream, not the downstream. Even the load is having open circuit or the circuit after point 3 is having any loose termination open circuit, it will not be able to detect it. This kind of measurement always detect the upstream. Actually, this is a very basic concept. Everybody should know. Okay, so now we measure here. So before we go there, let's look at the wiring diagram. Okay, motor selector 1.3. Okay, motor selector 1.3 located inside the control panel. Okay, located at the right side. Okay, upper corner. Okay, here. Let's go back here. Okay, as I say, we try to first thing first, we try to monitor the LED status of the PLC input and output. Okay, as we know here, okay, this is a PLC output switch module 2 channel 0. Okay, PLC output switch module 2 channel 0 is from TB31 here. Okay, okay, also, so what we can do here, okay, we can see whether there's a LED turn on. You can see PLC output switch module 2 channel 0, actually the LED channel 0 did not turn on. That means it can be due to, okay, the PLC output switch having internally open circuit, or the PLC output channel 0 LED is burnt or open circuit, or even due to the PLC logic's virtual output coil did not energize, maybe because the software is corrupted, or maybe because download the wrong programming. Okay, but this is extremely rare. We can ignore it actually, so we don't know. So when we see this kind of thing, our intention is, our thinking maybe is straight away change the PLC output card. But hold on first, don't do so. We try to check further before we change the PLC output card or input card. The problem may due to other circuit, may from other circuit, not from the PLC card itself. Okay, so we can measure the AC voltage, okay, from pin 3 of the motor selector 1. Okay, now AC voltage, okay, put here the ground point and then measure here pin 3. Okay, 0 volt. That means something is wrong with the upstream. Okay, look at the schematic diagram. Okay, schematic diagram for the control output. Okay, when we measure here, the voltage is 0. That means something wrong with the upstream. So we can measure here. Okay, we know that AC current actually go through, AC current will source the PLC output switch via the common point, the PLC common point. Okay, so meaning that is to say, okay, the current, the AC current will flow through the, will sourcing the PLC, okay, output switch via the common PLC common point here. Okay, AC current will source the PLC output switch via the common point of the PLC. Then it will sync the load to the ground or the neutral line. Okay, so how we should do is we can measure. Okay, now we can measure here to confirm the problem come from upstream, okay, not downstream. So we can measure, okay, by putting at the ground point and then the probe at here. Okay, PLC output switch module 2 channel 0. Okay, you see LED not, you see 0. That means, okay, the problem is from the upstream here. So it can be due to the PLC output switch open circuit, or the LED PLC output channel 0 LED is burnt open circuit. Okay, so even though we don't jump to the conclusion by saying that, by thinking that the PLC output card is faulty, we want to change. No, we should check the other circuit first. Maybe the problem is from other circuit. Okay, so the other circuit we need to check is, we know that this is the OL1 auxiliary switch thermal overload relay, but the input circuit, okay, or the schematic PLC input circuit, okay, also have another OL1 auxiliary switch. This is from pin 95, 96. This one is a 97, 98. Let's look at the wiring diagram. Okay, this is the motor contactor 1. This is the overload relay 1. So it got 95, 96, 97, 98. Okay, 97, 98. Okay, these both are the auxiliary switch attached to the overload relay. Okay, pin 97, 98 here is located, okay, connected to the PLC output circuit, while pin 95, 96 of the overload relay 1 is actually connected to the PLC input circuit, which using the DC voltage. So it is the two totally different circuits. Don't misunderstand. So we need to check this one. Okay, we know that this overload relay auxiliary switch most of the time always connected as a normally closed circuit. Of course, I don't deny, maybe in rare circumstances it may be connected as a normally open auxiliary switch, but it is quite rare if ever. Okay, so if this overload relay 1 is open circuit, current cannot flow through this PLC input load module 1 channel 1 to energize it. Okay, so it's possible. So we measure here. Okay, we know that the DC voltage, DC current will source the external input switch or sensor, then it will sync the PLC input load to the ground. Here is not the ground but negative. Okay, negative DC line via the PLC common point. Okay, so by looking at the wiring diagram, we know that okay, the DC voltage will actually source okay the external input switch or sensor, and then will sync the PLC input load via the PLC common point. Okay, oh sorry, it will actually, the DC voltage will actually source the external input sensor or switch and then sync the PLC input load to the negative line via the common point here. So we should measure, we put the black probe at here, then the red probe at here, okay, to measure the voltage. If you don't have voltage here, that means the upstream is open circuit or having loose termination. Okay, so what we can do is we put the okay PLC, actually DC voltage source, the external input switch or sensor, then sync the PLC input load okay to the negative line via this common point. So the black probe is here, okay, common point is the negative side, then the red probe is here, understand, here channel 1, just like this one, channel 1. Okay, input load 1, input module 1 channel 1. Okay, so we just came out here, sorry, so okay, so this is a PLC input load module 1 channel 1. So the black probe we put here common, and the red probe we put here channel 1. Okay, 0. Okay, what's the problem here? Here we put here 0 mean the upstream having issue, either open circuit or loose termination. Now we measure at 95, overload 1, thermal overload relay 1, 0.95. Look at the wiring diagram. Overload relay 1.95 actually from TB to 11. Okay, TB to 11 is here. TB to 11 to PLC input load module 1 channel 1. PLC input load module 1 channel 1. This one is from TB to 11. TB to 11. So we measure the voltage here by putting the red probe, the multimeter at 0.11 on TB2. So what happened is the current, DC current will come through here, divide into two paths, one path to the load, the other path to the multimeter. Okay, okay, it's somewhere around here. Okay, now so we can measure the DC voltage. So we put the black probe here, okay, and the red probe at the 0.11 of the TB2. Okay, so now you can see you're able to get the voltage here but unable to get the voltage here, meaning the wire here having open circuit or there's a loose termination at this point or this point. Okay, so in order to double confirm, we need to shut off the power supply. And then perform the checking. So do the lockout takeout. Okay, Sorry, the program is a bit lagging. Okay, now we can just remove point 1 here or point 11 here, either one first. Okay, I do this one first, and notice that when disconnecting, you notice that the connection will lose. So this is a loose termination. So what we do, we need to tighten it. So then tighten it. Okay, after tighten, we turn on the power supply. Remove the lotto. Okay, and then turn on the power supply. Okay, then you can see here the exhaust fan 1 lighting is turned on. So the problem